talk a little bit about this last part here. I mean, again, you don't have to study this in exam. I just wanted you to know because I think you will encounter this later on. But just briefly talk about this last part about the data structures down here. Okay, if you've seen this before, great, it's a review. If not, you will encounter this again. So data structure, this is a more advanced topic, but arrays are the basis of creating these type of data structures. Again, data structure just means the different ways of how you can store data in the program, right? And you heard about stack, queue, and linked list. These are three most common types of data structures. Any language you go and you learn about data structures, you will encounter one of these, if not all of them. And there are more. These are the three most popular ones. So a stack, in computer science, you always hear the term LIFO and FIFO. Okay, so LIFO means last in, first out. That means that whatever data you put in last will come out first when you retrieve the data. So it's like a stack of dishes. You put a stack of dishes on a stack. The last dish you put on top will always be the one that come out first. So it's last in, first out. Okay. So same thing here. So when you deal with stack, you have a couple of very common functions called pop and push. Okay, so when you push a data into the stack, so a stack, if you think of that as just a memory location somewhere in RAM or in the heap, and then you put a stack of data to that stack. So for example, here an empty stack will always have like the index of -1. So it's like a -1 index. It's you don't have that. It doesn't exist. Because again, there's no stack of index -1. So you always use that just to check the stack if it's empty or not. So you can say if type is equal to -1, then there's nothing in the stack. Okay, and then if you push the number 1 or the first data to the stack, then you will increment the top to +1 to it. So you do the counter, basically, you count that number, and then you push that to until the end of that stack, and then it will retrieve the data. You always retrieve the top item out of that list, and so you will pop it back out. Once you pop it, the data is removed from the stack, and then you have a reduction of the size of the stack. Okay, so this just means is the last in is always the first out for the pop. So when you hear stack, that's what it is. Stack is LIFO. The other one is queue. Queue is the FIFO or FIFO, how you would want to say it, usually at the F, first in, first out. So queue is, you see this all the time. You do a grocery shopping, go to a bank, right? The first person in line gets served first, and that's what it means. So you push an item to the front or to the bottom on the stack, and when you take it out, you always take the item from the top of the list. Not top, I mean like the first item you put in. So this, you will track the head of that list, and then you retrieve that data. So yes, the terms in queue and dequeue. So in queue means you pushing data to the queue, and dequeue you basically retrieve the first element from that list, and then you will reset the counter to the next previous one, and so on. Okay, so these are two very common ones. The linked list is more complex to understand, but this is also very powerful. Okay, because a list is, as you can see, it's a node here. A linked list is like you have a list of, I just showed you like an array of students, right? So students have a lot of data attached to that student, because a student can have like information about his or her courses, the grades, education, and you know, home addresses and employment, all those stuff. All those are part of, bless you, a part of this first node here, right? This is just showing you a string of characters, but it could be an object in here. It could be like, this is Gary's node, this is Alex, and this is Robert's, and so on. So you can access each of those by using what's called a pointer. Okay, so a linked list. You have a head, and then you have here the data itself, and then you have the next part here, which is called the node that points to the next of the list. And it forms a chain of data that way. And then the idea is just to make sure that this chain doesn't break. If you break the chain somewhere, then you actually lost the entire list of that linked list, and then you lost some data. So you always track the head and then the tail and where they go. Okay. Yeah. I just want to show you that one here, and this is again part of the arrays. This part here is actually will be covered. I'm saying will not be covered, but I mean it's like when you read chapter 9, then you will use that to create linked lists. Okay, because you have like a different type of data set. But these two are just like arrays, the single dimensional arrays. You can do that very easily in here. Maybe if you have time, I will post a code sample so you can test it or you can run it and see how things work. But it's very easy to do.